Hello everyone. Today we are going to see class 8 science chapter number 3 part 2. In a previous part already we studied about force, the different kind of forces like contact forces, non-contact forces, balanced force and unbalanced force. Today we are moving ahead and the first part what we will talk about is inertia. Inertia is very important phenomena to understand the motion. When we talk about a particular object, whether it is in a stationary state or in a moving state, it always try to remain in the same state. Simple example if I am taking, if you are sleeping, then early in the morning when your parent or your mother comes to make you wake up for the school, that time you tries to remain in the same state, that is a state of a sleep. Same way each and every object, whether it is a stationary or moving object, it always try to remain in the same state of rest or motion. This particular tendency of a particular object is called as the inertia. They have given the definition for the inertia here. The tendency of an object to remain in its existing state is called its inertia. For that, a best example they have taken over here. What you are supposed to do, take a one glass, one tumbler you can take, and keep a postcard on it or any piece of a paper or the hard sheet if you are having, and place a coin on it. What you have to do, you have to flick it from the corner. You have to hit it from the corner. Like we are striking the striker in the carom. Same way, just strike this postcard or the card sheet, and what you will find, this coin falls down in the tumbler. It's not going along with the postcard. Generally what we are expecting that it should go with that postcard, but it's not happening. Why it's not happening? Because of the inertia of that particular coin. It falls inside it. Another example if I'm taking, the best which you have might have experienced in your day-to-day life is that if you are traveling in a bus and you are standing and the bus is moving and suddenly driver applies brake, so what happened, you lean forward or you are going in the direction in which the bus was moving. Why this is happening? Because bus is stopping after the brake is applied, but your body tries to remain in the same state of a motion, and due to that we are going forward. Or the another condition if I'm taking over here, if a bus is at a stationary state and you are standing in a bus and suddenly driver starts the bus, what happened? We go backside or we go backwards. Why this is happening? Because bus starts to move but our body tries to remain in the same state of a rest. Same way, if the driver is suddenly taking left turn or the right turn, then we go on the opposite side. If the driver is taking a left turn, we are going towards right. So this, all the things whatever is happening is because of the inertia. We have three different types of the inertia. The first inertia is a state of a rest. The property you can see over here, the first inertia of the state of rest. An object in the state of a rest cannot change its state of rest due to its inherent property. This property is called the inertia of the state of rest. Same way, the inertia of motion, the first example which we have discussed of coin, that was the example for the inertia of the state of rest. Then second one, the inertia of motion. Object tries to remain in the same state of a motion. The inherent property of an object due to which its state of motion cannot change is called its inertia of motion. That example already we have taken. like bus is moving and you are standing inside, driver suddenly applies brake, then we go or we lean forward. It's just because of the state of motion that our body tries to remain the same state of motion. And that is called as the inertia of the state of motion. The next one, that is the directional inertia. The inertia for the direction. That also we discussed with the same example of a bus, and you are standing inside a bus and driver suddenly takes a left turn. Then what happened? We go towards the right, the opposite side of that. Actually, we are not going towards right. We are at the same position. If we are talking about the bus and you are standing somewhere and the driver suddenly takes left, we tries to go in the same state or same direction, and due to that what we feel that we are going towards right. Same way the vice versa, if driver is taking a left right turn, then we feel that we are going towards left. So this is nothing but what the inherent, so this definition they have given for this, that is the inherent property of an object due to which the object cannot change the direction of its motion is called directional inertia. So this is about the three different kind of the inertia. Next what we have to study is a pressure. Now here they were first, I'm taking this part, you must have observed the tires of two-wheelers and four-wheelers getting pressurized. Means we are filling the air inside it. The air filling machine has a pressure indicating dial on a dial meter or the digital meter and showing the pressure inside the tire. So why this is needed? By applying force, air pressure is increased and then the air is pushed into the tire. This is the example of the tire or the vehicle they have taken. Simply, if we are having a balloon and we are filling the air inside, so we have to apply a pressure on it. We have to fill it with the pressure, otherwise it will not blow or it will not blow up, or the size of a balloon will not increase. So that's something about the pressure. Now when we talk about the pressure, the proper scientific formula what we have for this is a force upon area on which the force is applied. For the pressure, when we talk about the force applied per unit area is nothing but the definition for the pressure. Force applied per unit area is the definition for the pressure. Okay, if you want you can note it down in your notebook also. Definition for the pressure: force exerted perpendicular on unit area is called pressure. According to your textbook they have given over here, and the unit for the pressure is the SI unit for the force is a Newton. Area is measured in a meter square, so a formula for this is a Newton per meter square, which is also known as Pascal because it's given by the scientist Pascal. And in atmospheric science the unit of a pressure is a bar, which is equal to the 10 raised to 5 Pascal. 10 raised to 5 Pascal is equal to 1 bar. This is the atmospheric science or the atmospheric unit. So that later on we will discuss that part. Now when we talk about this particular example of the pressure, we will discuss with the three different states. First we will discuss with the solids. You can see over here in this picture one stick is kept on the two blocks and the four different books are kept at a different sites on this stick. Then this pressure is applied in a large area. Generally the unit or the formula what we have for the pressure is a F upon A. Now here if this quantity is increasing, why this is increasing? Because book is kept at a large area, so in this area the force is applied. If this quantity is increasing, what will happen? The amount of a pressure will reduce. Whereas if area is reduced, pressure will increase. You can see here the more amount of a pressure will be exerted in this situation. Why? Because area is less. Area is less, force is the same. Why force is same? Because the number of books are same. Here 4 books and here 4 books, here also 4 books. 4 here, 4 here. But difference is what? The area. Here area is large, here area is less. So due to that, what will happen? This pressure will be more. You can see the shape of the stick is little curved. It's bending downward because it's experiencing a more pressure. Another example, they have taken the pressure in the liquid. Pressure in the liquid, for that the activity they have given, you can try at your home also, and if you're performing, you can post it, and comment section you can just post your experience. In this particular level, when we will see, or in this particular example, if you will see the plastic bottle and the number of holes are there in that, hole number 1, 2 and 3. You can see here, if I'm talking about the hole number 3, then only this much amount of water is applying a pressure on the water to flow out. So due to that, what happened? You can see the flow in this hole number 3 is much lesser as compared to the other. Then for the hole number 2, this much water, the amount of water is increased, so pressure will be little more, and that's why the water is going little far. When we go towards the bottom, then it goes little far from it. Why this is happening? Because liquid is also applying a pressure. Okay. Same way, what we are supposed to do, take a one empty bottle, make a hole, put the balloon in that and fill it with the water. What you will observe that water will get start to fill in the balloon also. Why? Because this water is applying a pressure. So there is a pressure in the liquid as well. Next is a gas, the gas also. If a balloon is inflated by filling air by mouth, it inflates on all sides. It means what? Whenever we are having a balloon and we are filling the air inside it, we are filling the air. What happened? It inflates from all sides, or it blows from outside. The size increasing from all sides. Yes or no? Why? Because air is applying pressure in all the direction, and that's why the balloon inflates from all the side. Okay, this is about the pressure in a 3 different states: solid, liquid and gases.